Building a failover cluster is a task that's hard, but actually managing that failover cluster, using it in day-to-day operations, is a task that's, well, it can also be hard too. Yeah, it's funny because failover clustering, it has the potential of doing so much, but there are reasons why when you see failover clustering getting implemented in certain environments, it sometimes has the effect of reducing availability. It has nothing to do with the limitation of failover clustering itself. It's just that there are so many buttons to flip and switches to turn, different tuning types of activities that can be laid into place, that it can almost be too easy to create a configuration that is nowhere near what you originally intended. My evidence of this is the fact that Microsoft has actually begun to include almost like skins over the top of failover clustering for a few key services. If you've played with Microsoft Exchange, and specifically Exchange database availability groups. When you create a database availability group, these actually reside on top of Windows failover clustering. But when you actually lay them into place, you never actually go through the implementation of a failover cluster. The DAG implementation has been skinned or has skinned over the WFC implementation, the failover clustering implementation. Another example of this sort of skinning over is anytime that you're using Hyper-V atop of System Center Virtual Machine Manager. Now, with Virtual Machine Manager, you still have the ability, unlike with Exchange DAGs, to dig into the cluster settings. But with Virtual Machine Manager, you can actually create the cluster from inside VMM, and then once created, manage all those cluster settings without ever really having to dig directly into the failover clustering manager itself. These two are two perfect examples of where Microsoft, I think, has kind of seen the light that people would like a general purpose clustering solution for some things, and then specialized cluster solutions for specific instances, especially those where they're particularly in a very high need for availability. Now, in this nugget, we're going to talk about the general purpose clustering solution and how you can implement failover clustering for literally generic services and generic applications. I don't want to talk, even though there's even an objective here that has to do with Hyper-V on top of Windows failover clustering. I don't want to talk about Hyper-V just yet, because I want to kind of separate out the complexity of Hyper-V from the complexity of failover clustering. And so in this nugget, we're going to talk about some of the specific role-specific settings that relate to a failover cluster. We're going to deal with some generic application, generic services. I want you to ignore completely the possibilities that you could implement on a failover cluster so that we can just focus on the settings themselves. There is going to be one, however, implementation that I do want to focus on, and that is this notion of continuously available file shares, or what is also called a scale-out file server, an SOFS cluster. When it comes to the exam, recognizing when you would implement a cluster-aware file service role it's actually fairly important. You got to know what the difference is between the traditional file service role and when you would implement a scale-out file server. The big thing you need to know, the most important thing you got to be aware of, is that with SOFS, this solution is designed only for the types of data accesses that are continuous, sort of long-running data accesses. These are things like SQL Server. These are things like Hyper-V. And so you use SOFS as a solution to host the files that SQL Server or that Hyper-V would need to use, because unlike traditional Office documents, these are the kinds of files that really never cease being touched by an application. There is no sense of them ever unlocking. In this nugget, we're also going to talk about some of the other settings as well, like failover, like preference settings. I want to dig a little deeper into role startup priorities. I want to talk about the node drain feature and how you could evict nodes. These are, again, just the buttons and switches that you can associate with any of the roles that sit on top of a failover cluster. And I also want to spend just a minute talking about guest clustering. Really, the only thing I think you should probably be aware of when it comes to guest clustering is that you can do guest clustering. What this means essentially is that you might create a cluster of Hyper-V hosts that have on themselves a couple of Hyper-V machines, that these Hyper-V machines themselves may be clustered using some sort of shared file situation. The neat part about this, the shared file situation in guest clustering, is that here inside of Server 2012, we now have the ability to use a shared VHDX file as the mechanism for supporting this shared clustering requirement. And kind of just, without getting into too much detail of how that works, because we don't have Hyper-V in place just yet, I want to show you how you can just implement VHDX, shared VHDX for guest clustering. But before we get into any of that, let's spend a minute here just talking about some of the failover settings that you gotta know. I mean, you just need to know these because they're common in every cluster everywhere, but you also need to know them because obviously they're going to be here on the exam. So here we are back in our failover, our cluster that we built. We've got 3 different hosts in this cluster, cluster 1, 2, and 3. Same 3 networks as well. Our storage, our heartbeat, and our production network. However, I do have one change here, and it's one that I kind of got to explain because I don't think I actually touched on it deeply enough back on that last nugget as we built the cluster. So in that last nugget, I talked about the difference between available storage and cluster shared volumes. And I told you that with cluster shared volumes, the idea here is that a CSV is designed to add additional granularity for the types of resources that exist on a volume. The one thing I'm not sure I did a very good job of spelling out is that CSVs are designed pretty much for Hyper-V and for Hyper-V virtual machines. So you're going to use a CSV anytime you're dealing with virtual machines. And for any of the other kind of generic resources, well, in those cases, that's when you're going to use your more general available storage. That requirement absolutely has an implication. And that is that when you begin to add cluster resources into a cluster, when you add roles, those roles are going to tie up these bits of available storage that you have. And so for just the same reasons that we talked about back on that last nugget about how I have to fail over the storage resource, the entire storage resource, be aware that once we create a generic resource or any kind of resource that's not a Hyper-V resource, I'm going to tag it to a bit of available storage, and that's going to be it. There won't be any additional storage that ends up getting connected to that resource or other roles that get connected to the storage. So just be aware of that because it may make more sense for you to connect up smaller pieces of storage instead of the very large ones like the terabyte and half terabyte storage that we've connected here. It all depends on the type of roles that you desire to implement. Up here under roles is the location where we'll actually create a new role that sits on the top of our cluster. Now you know at this point that, well, we have a cluster, but we're not doing anything with this cluster at this point. For us to be able to do that, we have to define which roles are going to sit on the cluster and be failed over between the cluster nodes. The types of roles that we have available are relatively generic in concept. So you can kind of see them here. I can do a DHCP server or a DFS namespace server. We'll talk about file servers here in just a second. An iSCSI target server. There's a WINS server down here. There's a Hyper-V virtual machine down here, down a little bit further down in the list. But the ones that I want to talk about here are these 3: generic application, script, and service. For the most part, you're really never going to use these except in the situation where you have some application where the vendor instructions have told you to come to this location to create a generic application or a generic service. More often than not, if you have a cluster-aware application, it's probably likely that the vendor will go through a lot of these steps for you. But I want to show you these because they are pretty much the most basic of possible implementations that we can lay into place so that I don't want you to focus on the roles themselves, but how you make the roles work. So let's actually take a look at a generic application here. And I'm going to actually even get as generic as I possibly can here and create a cluster-aware instance of Notepad. Yep, actually you can create a cluster-aware instance of Notepad. It doesn't actually do anything, and it doesn't actually work in any of the ways that you might think it would, but it does create for us an object, a cluster-aware object that we can then view the properties on. Again, like I said, I'm trying to focus you in here on the parameters and not so much on the implementations of clustering because it can get really complicated. Now earlier when we created the cluster, we created our 3 hosts. Here I'm drawing my boxes again. Here are my 3 hosts, and I created that virtual IP address that was the cluster address. I set that to, I think it was CLUS to cluster 1 was the name of the address. That's the management address that's used for managing each of the nodes that make up this cluster. But anytime that I create a new resource, I can create that new resource and associate it with another network name. So maybe I want to do another network name called Cluz Notepad here. And that ends up becoming another network name that has its own virtual IP address, to use a soft term, that ends up associating with the different hosts that exist here on this cluster. That's what I'm doing here, because my users, when my users are going to attempt to connect to these resources, they're going to end up connecting up to the Cluz Notepad network name that ties to the IP address, that ties to the resources here on the cluster. So let me type in here Cluz Notepad. And just like before, I want to take out my private network and my my storage network here and associate this with just an available IP address in my OneNet, just anything that's available. On this network, I have 1.222 available, so that's just the next IP address that's out there. When I choose next, I can choose what storage I want to associate with the Notepad role. Now again, when I set this, it's going to reserve it for use by Notepad because there's a dependency that's created by the Notepad application and the storage it's attached to. So I'll select that and choose next. If the application also has registry settings that need to be configured and also to be made cluster aware, I would add them in here. Now again, in this situation, it is more than likely that your application vendor would tell you what needs to be in here, or even more likely they would just do this for you. But this is the location where you would make the specific registry keys associated with this application cluster aware. When I'm done, I choose next to confirm, and it builds that cluster role for me. Now, anytime I'm building these cluster roles, what I'm actually doing is assembling a series of dependencies together so that the cluster knows what kinds of things need to get failed over in order to keep this application running. These dependencies I can actually walk through by right-clicking on one of my roles here and choosing to, let's see here, to show the dependency report. This dependency report gives me some nice information about all the different pieces that connect together to make up this role. So the generic application requires both the physical disk and the network name to be functioning. The network name requires the IP address to be functioning. Think of this as a dependency tree that identifies the types of things that can go down, and when those things go down, what might initiate a failover to keep the service operational or to bring the service back into operations. So let's think about this, right? So if for some reason I lost my network name resource, well, in this case, this requires both of these things to operate. And so because of that, I'm going to initiate a failover. Same thing up here. If I lose my physical disk, I'm going to initiate a failover. So you can use this dependency report to help you identify what types of things may be causing a resource to fail over. You can also manually initiate a failover if you want. Right now, this resource is currently existing on cluster 2, but if I right-click again, I can choose to move the resource to the best possible node, the one that makes the most sense from a resource perspective, or to select a new node for that resource, any of the ones that are up. Choose that resource. You'll notice it's going into a pending state. It shifts over to cluster 1, and then I'm not actually sure if, since this is not a real application, this may or may not actually power back on. Oh, yeah, it did. Very good. So it did power back on cluster 1. Okay, so you're looking for a successful failover event to occur. It is these failover events that are the reason why the cluster exists. So when I have that resource, and the resource is sitting here, so here's my Notepad resource. When I fail it over, that resource actually kind of pauses for just a minute as it fails over onto the new node. Onto the new node. There may be some cases, however, where the power on the new node doesn't work. So it may need to fail over to other nodes, or if I have multiple failures. That's why I would have generally, or want to have more than 2 different hosts that exist in a cluster to provide different locations, target locations for these resources to fail to. More often than not, with anything that goes beyond these generic applications, if you're talking Hyper-V, Hyper-V tends to require a lot more hosts in the cluster than just your average, Win server or DFS, cluster DFS instance. When we're thinking about these failover possibilities, though, especially as we start to increase the number of servers in our cluster, we have to start to think about where this role can fail over to, and then where this role should fail over to. So in this case, these are the possible owners and the preferred owners. P-R-E-F-E-R-R-E-D. There's either two F's or two R's there, I'm not sure. The possible owners are the cluster nodes that can host the resource. And the preferred owners is an ordered list of which ones we would like it to be hosted on. So maybe 3 is my preferred one, and then 2. This is the preferred order for those lists. And I identify the possible and preferred owners by looking at the properties of this resource. Here, as you can see, there are the list of preferred owners. Now, you don't actually see possible owners on here because the preferred owners and the possible owners are defined here by the order. The ones that are selected are the possible owners. The ones that are the order in which they exist is the preferred list. So what list do we want to see? Those that are at the top are the most preferred, and those are the ones that are least preferred exist at the bottom. So I got an ordered list, more or less. Now, in the case of a failure, there may also come the time where I may have multiple resources that are failing over at the same time. And because of that, I probably want to set some sort of priority for which resources are going to fail over first. This priority item allows me to identify whether or not I want to auto restart one of the resources when I see a failure, and if so, what order do I want that resource to fail over, high, medium versus low. Anytime that I'm doing failover is determined both manually and also automatically by any of the failures in the dependencies for this role. We talked about the network name dependency and the storage dependency. Well, I can also determine how many times I want that role to fail over before I stop trying to protect it anymore. This can be a little bit confusing here. In fact, even I get confused at this one sometimes, because this is the maximum number of failures that can occur in a 6-hour period before, if the next time that it fails, I just leave it failed. The whole point here is to protect yourself against a situation where a resource just keeps bouncing around because it just keeps failing over and over and over again. A good resource is one that shouldn't fail that often, so setting these to relatively low values is considered acceptable because you want to protect yourself from a failure, but you don't want to end up in a situation where that resource is just constantly failing and failing and failing and failing, and you can't actually get it stopped permanently to resolve the problem. The failback value here is one also that you should be particularly careful with. The failback value can have the inadvertent effect of bouncing cluster resources, especially if I set my failover values a little too much. The failback literally fails back the resource when the most preferred owner is back in a state where it can actually get that resource failed back. Be careful here, because you can end up in a situation where if you end up with too many failures and failbacks and failures and failbacks, you may end up into what I like to call a cluster bounce situation, where things just keep bouncing and bouncing and bouncing until it fails completely. I tend to set the prevent failback as the default setting. That is the default setting, but that's the setting I tend to do here, because other than failing things back in certain periods of time, I kind of would prefer that resource to exist on the target node, and then if I need to fail it back, I'll do so manually. Every so often with these nodes, occasionally I have the need to power off the node and fail over the stuff. Well, I can fail over things here by doing just what I did, by moving that resource. Or if I want, I can put the cluster node into what's called drain mode. Now, drain mode is very similar to the drain stop mode that we saw back in NLB. But drain mode allows me to, if I go here to pause, to drain all the roles off before I go about pausing the cluster service. Okay, very intelligent thing to do, because again, we have a cluster in place to provide high availability. Occasionally too, you may have the need to completely eliminate a node out of your cluster, to evict the node. Well, in that case, we have the ability down here to evict the node. This is a permanent activity. Once you evict the node, the only way to get it back in is to add it back into the cluster. So only do this if you're looking to either replace the node, get rid of it entirely. It is a permanent activity. There are a variety of settings too that are not available here in the Failover Cluster Manager and are only exposed through PowerShell. And there are a couple that you really ought to be aware of. You can access all the values here by just simply doing get cluster on the cluster node. So if you want to define which cluster you're looking for, you can. But since I'm in the cluster, one of the cluster nodes, I can do that here. Let me pipe that into a list so I can show you the long list of very specific configurations that are set on this cluster. So the log size, the core arbitration time period. I would be aware of a couple of values that can be configured that are associated with these heartbeats, that private cluster communication over that 2net that we created earlier. Remember when we did the cluster validation back on that last nugget, and one of the error messages that we got, the warnings, had to do with the amount of latency between a couple of the different nodes. The cluster heartbeat is particularly sensitive to latency. And so for that reason, there actually is the ability for you to adjust the amount of, or the number of heartbeats and the delay between heartbeats so that you don't end up with a latent network actually causing the loss of a clustered node inadvertently. These are the values same subnet delay and same subnet threshold. So how many milliseconds are there between heartbeats, and how many heartbeats can you miss before you consider that node no longer available? And then if you're doing a stretch cluster, it's cross subnet delay and cross subnet threshold. Okay, you might want to adjust those up. These are the default values. I believe these default values, the threshold value actually doubles if you're using this as a cluster for Hyper-V. So you can relax these if you want, but some of these settings these can be things that you might want to adjust, particularly if you end up getting that same error message that we saw earlier that had to do with a possible latent network. I do here want to talk about one of these special roles here that's it's important for us to talk about because it's the only role that behaves this way here in this version of failover clustering, and that is the file server role. Now for the file server role to work, we have to have the file server the role actually installed here on each of the cluster nodes. Once it's installed, and once we've got the appropriate disk that's been created, that's been provisioned for these servers, that's been configured as a CSV, then we can install the file server role for the scale out file server for application data. Now, let me bring back my 3 boxes once again. I kind of talked about this already, the fact that in just about every case, a resource exists on only one of the nodes of the cluster at a time, except in this one special use case that is an SOFS cluster where I have an active configuration. This is only with SOFS, and SOFS is only intended for server applications, you can read that pretty much as SQL, or virtual machines as Hyper-V, that leave files open for extended periods of time. It does not support NFS, DFSR, or FSRM. So this is really the implication or the addition of the SMB3 protocol and some of the other stuff that goes with SMB3 here with this version of the operating system. In every other case, and I should mention actually that an SOFS requires CSVs. It only works with CSVs, and hence the requirement up here. In every other case, you're going to use a file server for general use. Okay, anytime it's a regular file server, that's the type of configuration that you'll want to do. That's it. That's the only configuration you need to be aware of here for SOFS, because there's a lot of other configurations that that go into the creation of an SOFS server. But they really go above and beyond the scope of this exam. The only other topic to discuss here in this nugget has to do with guest clustering, and in fact it's kind of a misnomer here, because I think what Microsoft is really recommending that you be aware of as it relates to guest clustering is the notion of shared VHDX files. And again, I don't want to talk about Hyper-V just yet. I will come back to this when we get into the Hyper-V conversation. But there's a setting in Hyper-V Manager called Enable Virtual Hard Disk Sharing. That is what enables this ability to do guest clustering. And it makes the whole process much, much easier. So kind of hold on to this guest clustering for just a bit. I'll talk to it as we start getting into Hyper-V here coming up. But what have we talked about in this nugget? We kind of punted on this one, but we did spend some time talking about the generic cluster settings and the highly important continuously available shares, or SOFS clustering. New feature, going to be used for Hyper-V, going to be used for SQL. We talked also about some of the more advanced settings associated with failover, with drain mode, with some of the preference settings like preferred owners and possible owners, and went through a real review of the things you got to be aware of when it comes time to actually host roles on top of your Windows failover cluster. Coming up next, we're going to shift gears just a little bit, but not a whole lot, because we have to start talking about Hyper-V. We got a couple of different topics here, the first of which has to do with virtual machine movement. Now, in the old days, prior to Server 2012, in order to be able to do virtual machine movement, you had to have a failover cluster. These days, we don't have to have that because you can have shared nothing, clusterless Hyper-V live migration. Awesome, a really awesome tool, really cool without having to have that failover cluster. But doing VM movement can also require a failover cluster. So we're going to talk about it both outside the perspective of clustering and within the perspective of failover clustering. That's the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.